Most network time sync is measured in milliseconds, and that's plenty for almost everything you do online. One system, called White Rabbit, instead syncs clocks to within a fraction of a billionth of a second. Ordinary NTP, the kind running on your laptop right now, is genuinely good at its job, but its accuracy tops out around a few milliseconds, limited by unpredictable network delay. The Precision Time protocol tightens that considerably down to microseconds by timestamping messages closer to the network hardware itself rather than in software. But some experiments need far more than microseconds. Particle accelerators and radio telescopes spread across kilometers of cable, where even a few nanoseconds of mismatch corrupts the science. White Rabbit was built for exactly that demand, a single master clock feeding every device on the network over ordinary fiber links. Its trick data and timing signals share the very same physical fiber, and the system constantly measures that fiber's own precise delay. Layer that measured wire delay under a continuous exchange of precise timestamps, and the combined result reaches sub-nanosecond agreement between master and every connected device. Milliseconds down to microseconds, down to a fraction of a billionth of a second. Let's see exactly how White Rabbit closes that final, enormous gap. Take 1. Ordinary NTP measures round-trip delay to a time server and splits the difference, assuming the path there and back takes roughly equal time, a reasonable guess, but only a guess. That guess is exactly where its error comes from. Real network paths rarely take perfectly equal time in each direction, and queuing delay varies unpredictably along the way. Plain PTP tightens this by timestamping packets right at the network hardware, skipping slow operating system software, enough to reach microsecond accuracy, roughly 1,000 times better than NTP. White Rabbit starts from that same PTP foundation, then adds 2 further techniques layered directly on top of it, aiming at accuracy 1,000 times tighter still. Technique 1. Synchronization. Every device on a White Rabbit network shares not just a synchronized clock, but the exact same underlying tick frequency, distributed from the master over the fiber itself. With every clock ticking at precisely the same rate, small differences in phase become far easier to measure accurately. There's no drifting frequency mismatch to correct for separately. Technique 2. The network carries data and timing over one shared fiber link, using the physical properties of the fiber itself as part of the measurement. The system continuously measures the fiber's own physical propagation delay, down to the phase of the light traveling through the glass, timing the wire, not just the clocks at each end. That catches directional asymmetries a normal protocol would miss entirely. Meanwhile, both ends continuously exchange PTP-style timestamp messages, refining the estimate of exactly when each timestamp was truly sent and received. Combine the precisely measured wire delay with those exchanged timestamps, correcting for any asymmetry the phase measurement found, and the remaining uncertainty collapses dramatically. The slave clock at the far end locks onto the master's time with an error typically under a nanosecond, often specified as accuracy better than a few hundred picoseconds. And this isn't a one-off lab trick between 2 boxes on a bench. It works over real fiber runs spanning kilometers, the same distances found in large physics facilities. Chain switches together, each one relaying the same master timing downstream, and hundreds of devices across a large facility can share that identical sub-nanosecond precision. White Rabbit originated at CERN, developed specifically to synchronize timing systems across the Large Hadron Collider's enormous underground ring. It has since spread well beyond particle physics, into radio astronomy arrays, financial trading infrastructure, and national metrology labs that distribute reference time to other institutions. The design is also fully open. Both the hardware specifications and the software stack are published, which is part of why it spread into so many unrelated fields so quickly. The trade-off is deployment complexity. White Rabbit needs purpose-built switches and dedicated fiber runs, unlike ordinary PTP, which can often run over existing general-purpose network gear. White Rabbit layers a shared tick rate and a constantly measured fiber delay on top of precise timestamp exchange. turning ordinary fiber into a link accurate enough to sync clocks within a fraction of a billionth of a second. Thanks for watching. Next time you hear about a particle collision timed to the nanosecond, you'll know a system like this made it possible. Check out our other videos and follow how it all runs for more. See you in the next one.